Oh, let me make sure that I'm gonna give it like a couple seconds to make sure that the stream, but like warm up phase has passed. Takes maybe 10 seconds or so. And hello everybody, welcome to a 4Coder stream. Today I'm gonna be working on the wave function collapsing thing that I started last week. It had some bugs at the end, and I'm gonna be using the newest version of 4Coder. But I haven't actually taken the time yet to package the newest 4Coder build because I've got some new updates from the from last week. While we're waiting for the packaging to finish, I'll go ahead and let everyone know it looks like it's going to be another week before I've got this ready to go, just because Friday is only a couple days away now, and to release what I've got now, I don't think I want to do that. There's still a number of like core issues with the wrapping that I want to tune in, and once I've done that, I have a long list of like small other little things like, oh, on this very rare issue come up for these people, and we want a little flag for doing that and the customization, all that stuff I haven't even started yet. And I try to do a little bit of that every build to help people who are using 4Coder, so I have to do that, which is going to take a few days. So it's going to be at least as long as next Friday before I can send this out to everyone. But I think that that's not an unreasonable time to start expecting the 4Coder 4012 to come out. Let me go ahead and get my new version up and running here. This newest version has slightly improved wrapping rules. It has a little backslash on wrapped lines to indicate where they're wrapped. Uh-oh, I gotta go to here and there we go. There we go. Hey, Tiny Inky Crab. Yeah, this is totally inspired by the C# GitHub one. In fact, we'll probably be referencing that code at some point because I'm just looking at how they did it and making some adjustments. Now, the first thing I'd like to do is last time when I finished, there were some bugs, and I need to get onto 4Coder. Let me actually close out irrelevant stuff. Alright, so here we are. Now the issue was it wasn't working. So let me update everyone on where we are. The way this is supposed to work is you put in some samples, you give each sample a frequency or like a weight, and then it's supposed to generate an output that's larger than the size of the input samples. And each of the, if your input samples are, for instance, 2x2 blocks, then for every 2x2 block in the output, that 2x2 block should be one of the samples, right? And furthermore, it should roughly be true that each 2x2 sample, the probability of that sample is proportional to the weight you gave it, right? So what I have right now is these are my samples. I'm just hard coding them in. They're 2x2. There are 6 of them. So this is one right here. This one over here is the second one. Let me, by the way, make sure I've got code wrapping and virtual whitespace on. Alright, we do. So this one right here is one of the samples. This one right here is one of the samples. Let's see. This right here is one of the samples, and that right there is one of the samples. So that's 6 samples, and each sample, if you look at them, the rule is basically every 2x2 block has 2 zeros and 2 ones. That's what I'm trying to get it to do. Right, so there shouldn't be any 2x2 blocks with, say, 4 ones, but that kind of happens all over the place. Like right here is a 2x2 block with 4 ones, here's a 2x2 block with 4 zeros, and everything in between. So there's definitely a bug, and it's not clear to me what would be causing that. Now, what we're going to need to do probably is debug it. That's the only way I can think to do it, is just pop open my debugger and walk through and see what happens. It could be a problem with how I'm propagating information. That seems like the most likely problem. Ooh. Get out of here. I think last time I went the whole time without ever using a debugger, which meant I never had to come in here and add like a debug flag. Tiny Eager Crab asks, are you planning on adding a debugger to forcoder? I think at this point I kind of have to, and soon, and the reason for that is now that code formatting is there, the more I go down that road, the more different the code will look when you switch over to the debugger. Like, if I do this right now, it'll be fine probably, but once in a while you might see like, oh, that code looks kind of odd in the debugger, and the reason it looks odd is because it's formatted differently in the text than it is on the forcoder presentation system. So at that point, you either have to care about the format of the text anyway, which defeats the whole point, or you have to have a debugger that formats your code. So I think the debugger has to come soon, but that doesn't put it before. There's still like important stuff. I have to get Unicode, and I have to get pure data buffers for other purposes, and I have to get undo fixed up. I have a lot of like the core systems need to be there before I can make that change. So, Strange Jack, I don't know the difference between ZI and Z7. ZI has always worked for me, so I don't know. I just always use ZI. What does Z7 do? Strange Jack, right now the reason I don't have a debugger is just because the core system that would allow me to have a debugger isn't there yet. Like once it's time to implement a debugger, I'll call on everyone. I want to have a Mac port ready. And then I want to say at the same time, all of us on our different Mac porting people, let's get the best debugger implementer we know for each platform and get them working on the debugger portion. I'm going to work on the unifying portion because I want the debugger to be the exact same on every platform. If we get to the point where forcoder has a debugger that is identical on every platform, then we actually have solved like the biggest problem that there is in cross-platform production as far as the biggest one I've ever encountered, which is that I can't set up the same environment everywhere. Once I've got that, my environment can literally be the same everywhere, because I can just run Clang or switch to specialized compilers on Windows if I want, and debug and edit in exactly the same way on every platform. Anyways. But yeah, my number one concern is not only making sure that we have competent implementations for the back end, but the front end for the debugger needs to be identical in all situations, in all platforms, for all debugger backends, for all compilers, and so on and so on. Ginger Bill, what's Copenhagen interpretation? Is that what this algorithm is actually called? Okay, this is irrelevant. Bunch of coefficients. Then we do the collapse rule. So we observe a thing, which means we iterate all the things. And you can see here where the code formatting is just kind of fucked because it's you know, it's based on totally random shit. Alright. Sample count, blah 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 blah. So I get an entropy, it's like 1. This is something I've been thinking about, and it seems like the entropy is always going to be positive. The more I think about it, because even when this here is negative, this will always be more negative then, right? I mean, I don't have a proof because there's like it's muddy, it's a little muddy, but it seems clear to me that this has to be more negative than this if this is negative, and less negative than this if this is like less positive than if this, right? So this minus this should always be positive. It's one thing I've come to conclude. So the only time we get 0 is when there's only one sample at all, because then these are equal, but we also just shortcut that right here. So anyways, I get some noise. The noise came out as 0. I wonder if the noise always comes out as 0. I feel like the noise should be bigger. Okay, anyway, so I add something there. The entropy is a little bit noisy now. Probably not enough. Yeah, I want the noise to be bigger, maybe. We'll see. And that is smaller than what our current min entropy is, and then we blah 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 blah. So we've got a best x and a best y. It happened at x equals 0, y equals 2. So we're good. Then we get a pointer to the cell coefficients for that. So what we did was we took the best x, best y times width, multiplied that by the number of samples. That's correct. We do a die roll, which means I roll there and I get the best total weight. Okay, that's the total weight of all the cells that are still available here. And then I get a pointer to the weights on the samples. I get a stride value. And what I want to see is the weight putter behaving correctly here. So it's pointing at a 1 right now. Hit element equals sample count. I see. We're trying to figure out which element we hit. We subtract 1. Now our die roll was originally a 4.4, which means we're going to hopefully land on the fifth one. Okay, so that's still a 1. And blah 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 blah, and hit element equals 4. Oh, it's the fifth one, the fourth index. We're good. So if hit element equals sample count, we have a problem. It doesn't. T equals 0, go across the sample count, and then, so the cell coefficients array, it's initially all 1s. We should be setting that one to 1 and all the others to 0 at this stage. Badoop. There we go. Let's see. XY changes equals change count plus 1, new change. So now the changes, the first change anyway, which is changes 0, is 0, 2. Now I go to the propagation stage. Now for propagation, I'm always looking at changes I, and I have come up with a way to optimize this more because I made one mistake when I was setting this up. I didn't consider one thing, but I changed how this worked versus C# one a little bit by just making a queue of the changes rather than iterating the entire array to see where changes occurred, and then every time you're done, if you did find at least one change, you go and iterate the whole output array again. Instead, I just have a queue of what things actually changed, and you just pop off that queue. So when the queue's empty, you know you're done. You don't have to go through spots that didn't change and skip them or anything like that. But what I still need is the ability to, if something's already in the change queue, not add it twice. Which isn't really hard to do, it's just I didn't think of it before, and so now we gotta do that. Now what just happened? dx equals sample width. Sample what? I equals... What was that? That was weird. Change count was 1. Changes... Yeah, I don't think I understand what just happened, but something bad happened. Okay. Changes I looks good. Change count is good. dx becomes -1. While it's less than 2, we keep going. dy becomes -1. While it's less than 2, we keep going. But it didn't keep going. -2 plus 1 is less than w. I'm confused. Alright, let me change something real quick. Line 317. Let's see. Unsigned short. Do you see this? The debugger is telling me that that's an unsigned short and the dy is undefined. What the hell? What is sample width? That's an unsigned int. That's crazy talk. It's not an unsigned short. It's an int 32t. What are you talking about? It already sees the dx? Where did you get a dx? How can you even have a dx defined? There's no other dx's anywhere in the code. Okay. What the fuck? Unsigned short. Oh, for fuck's sake. Okay. God damn it. So what does like C not have warnings for signed unsigned mismatch? C++ always gives me a warning for that, so it's different. There. Hey, what's going on there? Why aren't you wrapping right to there? Open parenthesis, close parenthesis, open, close, open. What do you know? That's a bit odd. Oh, that's because now it's doing this. I see. So that means it got the parenthesis wrong there? That's a bug. That's fine. In the meantime, what I can do is say, let's go down to the matching close bracket here, up to the matching close bracket, and just put one in right there, and now it should work. It was fun while that double for trick lasted, but now that I have like, yes, I wanna add more flexibility to that rule because I liked the way that was working previously anyway. Ah, shit. You guys are right, I didn't do this. I have to do this. There we go. Good catch, Mickle. Alright, so... yeah, there's all kinds of bad shit going on in here. So this... is supposed to be like this, maybe? No, actually... I'm not sure. So I'm making that negative. Well, you know what? Let's just take the bit not and add one. Whoops, not accent mark. Please add one. If you don't know, anytime you have an unsigned integer and you like convert it to an int and you treat that as negative. If you don't know your choose complement, here's how it works. You bit not it and you add 1, that's how you get the negative. So you can get the same bit pattern that you would have gotten with signed integers by using that trick. Signed to unsigned mismatch. So t is signed, the sample count is unsigned. No need for t to be signed, we can be unsigned. Next. Next. Again, you can be unsigned. Next. Again, you can be unsigned. Next. Hit element, that can be unsigned. Next. T can be unsigned. Next. Alright, T2 can be unsigned. Next. T1 can be unsigned. Okay. Min x versus delta x. Okay, no need for these to be unsigned. They can be signed because they're going to be small anyway. But then it's going to complain because sample width is unsigned. That's fine, let's just cast it. So the sample width and height should be signed, it looks like. Whatever. I should have a block paste. That would be cool. Like, you know how you can do shit like, oh, that's wacky. I have to mess with how that works with code wrapping, I guess. Okay, anyway, let's see, what do we got here? Yeah, so you and you can be signed, I guess. Move. Interesting. There we go. That might fix our bugs right there, actually. So let's take a look. No. No. That didn't. That's not good. That's only bad. Yeah. So the next thing I want to do is output. Where's my output string? Please memset the output to 0. Okay, so yeah. And now it's just writing nothing because presumably it's hitting a contradiction, I guess. Failed. If I equals 0, failed equals 1. No, not that one. This one. I'm assuming we're hitting this, but we might actually be running out of memory in the changes queue too. Ah, we are. Ooh, PD Codes is hosting me. Thank you so much. Alright, so let's see. So it looks to me like the next thing we need to do is deal with this issue I was telling you about before, where when we're propagating, I always push onto the list even if it's possibly true that this change already is queued up on the list, right? Because it could be that like the center changes all the things around it, and then like one cell changes, and then all of its neighbors change, and then you do the top left corner, and then that changes all of its neighbors, which means the top center piece has changed twice. So it's actually on the queue twice. So is the bottom, the middle left spot. And then when each of those is changed, it's going to push everything on there again. It's not necessarily always pushing everything on there, but very often the same thing could be on there many, many times. So to eliminate that, I'm going to add an array um, of which things are changed. And the way we're going to get that array is from the scratch. So right now the scratch just looks like that. I'm going to extend it to have a uint8t cell changed, or cell on change queue, something like this, equals, and then I need a uint8t pointer, and I need that to come from scratch, and then let's see. Cell count equals width times height. Mem set cell on change queue to 0. Sample count. No, cell count. And then right here, what I need to do is I need to take cell on change queue plus cell count. There we go. Alright, so first of all, everything says it's not on the change queue at first. Now down here, whenever I go to add something to the change queue, what I want to do is I want to say, alright, actually, this is a good time to pull this out into a separate little helper. So, doop doop doop, static void wave2d add change, wave2d change, and then I just have to pass in the wave2d changes, the uint8t let's call that on change queue, the on change queue array. I probably need the let's see, uint32 width to index that, and up here I need the change count and the change max. So I have a question for everybody. Why on the left-hand side is it putting the look, it's putting this, forcoder in particular, is putting this right here, but up here it's putting it right there and right there. It's like putting it where the line ends. Down here it's doing it where the wrapping position is. And also, why the hell... Oh, it doesn't know about that being sticky. Should have wrapped it like that, but it doesn't know better. Okay, so I need a notebook to make a couple notes here. 1 second. So, wrapping after ampersand is a no-no. What the fuck is up with the slashes just going wherever the hell they feel like? Okay. Josh Hutcherson? I'm not sure who that is, so I don't think anyone's ever told me that. What did Josh Hutcherson do? Nothing bad, I hope. Ginger Bill disagrees with you, so we're all good. I don't look like Josh Hutcherson. Alright. What the serious fuck, though, is up with these slashes? They're not supposed to behave that way. They're supposed to go where it's wrapped. At least that's the setting I have it on. But look, all of these are going as far to the left as possible. Yeah, that one too. So question, where is... That one's at line 290. Oh, that one too, huh? It's as if it's using the wrong setting to render it. How could it be using the wrong setting? It's got something to do with the view. Although, to be honest, I like the right-hand side one better than the left-hand side one. But still, what is that about? Okay, so here we are. We're adding a change. We just need to go changes, change count, plus plus. This is going to need to return like an indication of success, equals, the new change. But that's only if on change queue change.x plus change.y times width equals 0, right? Then you can do that. And by the way, then we can have result equals 0, result equals 1, return result, and then on change queue change.x plus, why don't we just do I equals 1, and then up here I equals all this, right? And of course that could be unsigned. And now down here I just need to go wave 2D add change, changes, wait, new change, changes, change count, change max, on change queue, W, No, no, don't. What are you doing? No, fuck you. Alright, there we go. And we want to take the added change result like that, and here we're just going to assert that we added a change. Now, do I have asserts? No. Okay, then in that case what we'll do is if I added a change and I failed, then we'll go to finished. How about that? Just had a thought. Allow wrapping first parameter sometimes and indent as tab, not parent line. There we go. Doopy doopy doo. Let's see. So I know how to add a change now. So I'm going to grab all of that. I might just grab all of that. And down here, change count. Again, if we fail to add the change, then we failed and we go to finished. Derp! The compiler screams at me. What's bugging you, compiler? Tell me. Tell me all your problems. Missing unit. Unit 8 is not correct. uint 8 is correct. On change Q. Alright, there we go. Hey, that didn't help me. Alright, so it's still giving me all zeros, which means somewhere it's set and failed equals 1. So what I want to do is stop right there, get a watch on that, get an address from that, move that address over to the left, copy the address, pop over here, get a new data breakpoint, add it, there we go, and now finally, aha! So we failed to add the change right here, and the reason we failed to add the change is because the change count is 5 and the change max is... The fuck? Oh, I see, I see. So, okay, so we're going to assume success. If the thing is already on the list, we won't add it, but we'll set result to 1, like so. And the other thing we actually need to do that we're not doing here is we need to check if change count is less than change max, then we can do all this. Else what we need to do is set the result to 0. Right? Now, down here when I do added change, I need to make sure added change explicitly equals 0 or 1, right? And then down here, when it's added change, and you know what, I'm hacking this, let's do this properly. So type def and enum, don't need to type def and enum, let's just enum wave to the add change result, add change success, add change success already on queue, add change failed, okay? And we'll assume add change failed, and then here we'll do result equals add change success, and down here we have add change success already on queue. So here what we care about is that add change must not equal add change failed, and added change here must exactly equal add change success. That's why I'm sort of struggling with this. I'm trying to get it to express two slightly different things. There we go. We went ahead and codified it. One other thing, always put the failed case as 0 so that you can if on it without being wrong if you only have one failed case. Alright. We're still failing at some point. So, let's see. Breakpoint right there, run it. Get that address, add a data breakpoint. Oh, for fuck's sake. Copy that. Don't know why there's not a built-in feature. What the hell? There we go. I don't know why there's not a built-in feature like right-click, add data breakpoint. Makes no sense. Makes no sense to me. What? So we didn't fail at any point, is what you're telling me? Copy, add a data breakpoint, paste, turn that off, and let's go ahead and put one right here. Doop. Oh, for fuck's sake. Okay. We are failing. I'm just using the wrong thing because of this super broken GUI thing that's happening to me. So I move that right there. Get a copy of that. Now, not break it function. Break it data. There we go. There we go. So, what's going on here? Change count did not succeed. What did it come up with? Oh, I got that backwards. That should be if it does not equal that. Okay. Got the polarity wrong on my equality tests there. So let's see what we get now. Still all zeros. So here we go again. Delete that. Run that. Hit the first breakpoint. Delete that because it changes every time. Copy that right there. Copy that. Add a data breakpoint. There we go. And run it. And there we found the valid sample count equals 0. So we hit a contradiction, huh? Interesting. I'm curious about why that's even really possible. which cell is this? 0, 0. Alright, let's simplify the case, because it's saying it's hitting a contradiction now, which means we need to pop up here, and I'm going to make a simpler hard-coded test. Uh-oh. 4-coder bug. Let's try and retry that. That's not going to let me attach a debugger at this point. On stream crash. Alt I. I believe that that's a bug that I had way back in the old days and then I fixed, but my switch to the gap buffer probably exposed that bug a second time. And I couldn't remember what the bug was, so I didn't find it when I was auditing the buffer code. Alright, so our issue here is that 4-coder is not running. And now I want to try to hit Alt-I again. Oh, it happened again. Equals buffer line count. So it's always caused by the same, it's somehow like when I add multiple lines with a single or a double or something. Maybe it's a batch edit problem. This is happening in buffer abstract. Well, can't use Alt-I for now. We'll have to look into that. Not used to having to type that out. But I want to reduce this all the way down to just one sample. So we should never get a contradiction because this can tile infinitely. It should work. Should work. I guess it depends on the size of the output. If it'll work. Yeah, the output should allow it to work. Okay, so now I want to run it. Still failing. So there's definitely something wrong in the thing that tests for contradictions, not in the actual sample set, because that sample set should work. So here we go. Blah blah blah. Doopy-doo. Doop-de-doo. Copy that. Blah blah blah. There we go. What the hell? Alright, so again, it's not telling me that anything failed. Let me put my breakpoint right there and see if indeed nothing failed. No, it doesn't say anything failed. So now what it's doing is, for each point in the output, for each of those, gives all the cells. T equals less than sample count, which is 1 if T cell break. Sample equals blah. Oh, that is actually wrong. That should have led to a contradiction. What? Okay, so something's definitely failing somewhere. And I also realized that even though I did the work to make sure I'm not running out of, like, that I have the is changed thing, I didn't actually Oh wait, no, that works. So, um, yeah, something's going wrong when we propagate information though, because that should have led to a contradiction for sure. Actually, let me do one quick thing. Turn that back on. Alright. So I just auto-indented all of the code so that it would stop having that weird formatting thing. So, why is the propagation not ever failing? It seems like it should fail pretty quickly, actually. And now I don't have it built. What? What the actual fuck is this? Okay, break right here. Okay. So it's gonna iterate all those. Should eventually make a decision like, oh, I'm going over. What? Alright, let's take a look. It's coming through here. Valid sample count. Does it ever hit this? No. Does it ever hit best X, best Y? Oh, they all have one value already. And so you think you're done. That's really fascinating. Suggests the fact that the correct way to do this is actually at any given time to know which ones you've finished and which ones you haven't finished separately. But yeah, let's actually do that because I feel like that'll speed things up too. So up here, when I'm getting this other stuff, and you know, actually I messed up something else that I should fix up, but let's do this real quick. T cell finished equals uint 8 t star on change queue plus cell count cell finished, and then this is cell finished plus cell count. But what I actually want to do is I want to have like scratch putter equals scratch scratch putter uint 8t scratch end equals scratch plus scratch size, and do it that way. And then this here is scratch putter, and then afterwards we plus equal that by cell count, and then this here can just be scratch putter again, and then we increment by the cell count. And then what I want to do is something like set this equal to uint 8t scratch plus scratch putter minus scratch, which I probably have to cast again. Or let's do int 32 position equals all of this. That might need a cast to int32, and then I just need to do the sort of round up thing, so I want to round it up to the size of wave 2D change. That's going to need at least 8-byte alignment, so position equals, let's see, what's it called? We do position plus 3, and the bit now of 3, right? Yeah. Okay, so then we update scratch pointer thusly, and that gives us this scratch putter, and then this here is scratch putter minus scratch start, and I decided just now that there should be a scratch start. Like that. Sraj. I spelled it wrong. Wow, I'm so dumb. I'm terrible. Okay, there we go. That should be scratch end minus scratch putter. There we go. Not done yet though. Now I've got the cell finished array. Right. And what I need to do is when I'm in here, entropy, I'm picking between 0 and 1. This value here, I said I want that to be a little bigger. I'm going to do that outside of here. I'm going to pick the noise up here. And then what I'm going to do is say, look, if this cell is finished, right, then entropy equals, technically I don't even need to do any of this, okay? So what I'm going to do is say, get rid of you, get rid of this case entirely, and then entropy plus equals noise can go here, and this can go here, and then what we'll do is we just say it's up here. We do, look, we don't even bother doing any of this work. Unless the cell is not finished, right? And the way we find out the cell is finished is like so, right? So there we have it. And by the way, I also have to set that to true whenever it is finished. If I get a best x and a best y and I'm not done yet, then the first thing I'll do is I'll set that to be finished. Doopy doo. Doop. Doopy. Best x. Why is that indented up there? Did I add a brace at the wrong spot? No. Oh, so why is that indented way down there? I just didn't auto indent all this, so this is all shifted back in the weird way. I see. I see. Alright, let me go fix that because it's going to bug me, and I gotta set 4coder up to have a mode, in this mode, like always auto indent on save or something. tab, build it again. There we go. So we got a best x and a best y. We set that to finished, and so on. So now what I want to do is at some point, somebody should definitely reach a contradiction and fail. I feel like this shouldn't be getting checked here. That should be getting checked during propagation because it's easier in that situation. We're making the change then, we should catch it then. But I'll leave it in. Don't want to break it at function, I want to break at data. And there we go. So we did find a case where the valid sample count hit 0, which is, like I said, what makes sense in this case. Okay. Whoops. About an hour in. Alright, so now our next phase is let's see. So yeah, let's come up here and let's make a small change to our... Oh, what's that? Is that because I don't have... Ah, okay. Okay, so let's see, let's add another one. And let's make it this one, but the other way around. So the idea is we have one that makes a slant in this direction and one that makes a slant in this direction, so that two neighboring spots can have opposite, and we should just get a perfect checkerboard now. But we didn't. So what happened? Well, let's take a look. At some point it failed, and our job now is to figure out what it did that for. What kind of failure did we hit this time? Okay, so we eventually still hit valid sample count equals 0. Seems like that shouldn't have been possible. It might have just made a bad call about yeah, so what we should do is say, let's print it incrementally. Propagate. So we do an observation, we do as much propagation as that observation will allow, and then every time we're done, if I have it enabled, I will do something kind of like this. I'll do a for loop. By the way, didn't we say we were going to do these like this for now, since it doesn't indent them the cool way anymore? Then blah. There's one of those issues I gotta fix. Large pastes screw it up and you have to insert another character to fix it. So let's see. what I want to do is, instead of printing anything out in this case, okay, I need to invert the order of x and y, and alright, so blah blah blah, then I'm gonna printf the digit. Well, actually, what I want to do is I want to say, look, if the cell is finished, and by this cell I mean x plus y times the width, do one thing. If it's not finished, do another. In this case, please just print a question mark. In this case, please print a digit corresponding to the value you get from this. Right? So I get the cell, I blah 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 blah, and there we go, some blah 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 blah. Find the right one, print it, and then after each line we need to printf a new line character. Two? You can't have a two. You can't have a two. That doesn't make sense. It's ridiculous. Okay, so it's putting a 2 right there. And what I need to do now is I realize that after each round I'm going to want it to print an extra new line at the end to separate them out. And then what I need to do is ask, why the hell did it think it could print a 2? It's ridiculous. It's ridiculous. So hit cell T2, it means that all of those in that cell are 0, but how could that have been the case? Best x, y, if that came out as a 0, then if that came out as a 0, 0, then that would all make sense, but it would have put cell coefficients right here, and it would have said roll a die between the best total weight and 0, and if it had been sample count, we would have failed. And then hit element, cell coefficients. They can't all be 0. One of them has to be a 1. Doesn't make any sense. Okay, 364. And by that I of course mean 363. Hey! There we go. So t equals 0, hit element equals 1, best x, best y are in fact 0, 0. We do that, it's false, so cell coefficients there. What is all this crap? Get rid of that, I don't need any of that. Cell coefficients 2. So the first one becomes a 0, the second one becomes a 1. I push the best x, best y as a new change, so the changes at position 0 should say 0, 0. It does, good. We didn't fail. Then we go to propagate. And what we do is we get the delta x and the delta y's. We pick so that gives us an x2 and a y2. Change.x, change.y. That came from 0, minus 1, modulo w, modulo h, cell 1, and cell 2 is whatever cell occurs at that location. Okay, okay. So let's take a look at those. That should be cell 1, 2, and cell 2, 2. Alright, that all looks perfectly normal. We then take a look and say, alright, cell 2, we're looking across all the samples. Can this potential sample, can sample t2 equals 0 coexist with the thing we picked here? And the answer should be yes. The answer should be yes, it can. So it goes, okay, cell 1, t1 is not the case. So what I need here is, once I've decided I've finished a cell, I should store in that cell which one I'm using, because a lot of cases I bet this is where it starts, and then it could be a lot faster to just determine, like, if the cell's finished, use the one thing, otherwise do the loop, right? Okay, so here we are with t1 equals 1, t2 equals 0. These should be compatible. Can coexist. Check results. Okay, sample 1 and sample 2. So we have sample 1, which is 4 bytes long, and sample 2, which is 4 bytes long. Why on earth is it formatting these two differently? That's odd. Don't care. Oh, maybe because this is the beginning of the array and that isn't. Okay, and then min x is less than delta y x. It is not. If max x is greater than delta x plus, okay, so that's a 2, and that is too big, so that becomes a 1. So our min x is 0, and our max x is 1. Our min y is 0, and our max y is 1. So that means there's the overlap. We have two 2x2 blocks, and the amount of overlap they have starts at 0, 0, and goes over, like, has the size of 1 in both directions, right? Then what we do is we say, okay, here's sx and sy. These are the actual, like, sample x and sample y that we're pulling stuff out of. So for sample 1, I just put that in there, and I get 0, 0 is my position. So there's the thing value I'm going to check it against. And here I subtract out delta x and delta y, which makes this a 1 and a 1, which 1, 1 is this one right here, and those are not equal. So they can coexist becomes false. Now, I said that should be true, and I was wrong. That should be false, because these two are not neighbors, they're kitty corner. Right, so if they're kitty corner, then they have to be the same sort of parity. And there we go, we're done checking. Can they coexist? No. So that these two samples cannot coexist with one another. Can coexist equals 0. Set that. Cell 2 is changed, and then we pop back up. Cell T2, can it coexist? We don't know. Loop across, try the first one and skip it, and then coexist check result. Sample 1 is blah, sample 2 is blah. Now these are the same samples. These should agree with one another. We again get the same thing. So, you know, all of this is kind of fucking stupid. These are going to be the same every goddamn time. These should be hoisted like 2 loops out at least. Yeah, those could be hoisted 2 loops out. So there's definitely dumb shit going on in that C# code we looked at last time, because these become 0011 again. Then we loop across, and we could really right here just hoist all of this out entirely and invert this and come up with the list. Okay, I think I have a plan on how to speed this up. Okay, so SY, yes. Okay, this is 0, 0, so it's reading from there. This over here is 1, 1, so it's reading from there. They are equal, so they're fine. And that's the whole amount of the overlapping section. So these indeed can coexist, so we don't rule that out, right? And we go, okay, good. Cell T2 changed. If they cannot coexist, oh, that should be a 1. 397. Okay. Alright, so there's a very easy thing I can do here that'll speed this up a little bit. So I'm going to go ahead and do it right now, which is to hoist this up here. Because that is all completely independent of the sample that the sample pair we're actually comparing. So we can just pull that out. This part's a little more complicated because it depends on sample pairs and on their relative positions. So I'll leave that right where it is. And here we're getting that, doing the coexist check. And the reason that was the other is because in the C# code, that this whole coexistence thing was a subroutine, and so it was sort of natural for that code to be written that way. If you didn't care about speed and you just kind of wanted to implement it in the first way that your brain thinks of, it does kind of make sense. So there we go. Cell T2 and blah blah blah. And what we're going to run into here that's kind of a problem is when we do that, we need to immediately, if two things can't coexist, then right here what we need to do is say check for a newly finished cell / contradiction. Alright. Still not correct. Now it's putting a 1 there, which is better, but it's still not correct. Okay, so right here is where things kind of get interesting. Let's make sure I've built and run to there. I'll leave that breakpoint in. Maybe pop it up here. Okay. So, in best x, best y, we're 0, 0. So now we're coming down here, pulling out the delta x, -1, delta y, -1. We're getting the overlap region there. T2, T1, T1, they cannot coexist. We break out, we put that there. can coexist. T1, T1, 1, 2. Those can coexist, so nothing bad happens. And cell T2 was changed, so if the change count equals change max, we do stuff. We set the new change to be there, and we add it to the change list. If that failed, it didn't. And then we go look at the next cell here. So this should continue for a while. I want to see the next thing we pop off here. So the change count is now all the way up to 9, and I is at 1. And we pop off the change 2929. We pull stuff off. Oh, this is eventually, I see what's going to happen. So we don't want to push, well, I'm not sure if this will happen, because it shouldn't ever change something. It should never set cell 2 changed to 1 unless this happens, and eventually that should stop happening. But let's see if we eventually get to this case. No, we don't. So we didn't fail. Or we didn't fail this time through, I should say. That was not the end of the algorithm. Okay. And then we print out the cell finished, and this is where we have an issue because it doesn't know that a bunch of cells are finished. But the first one is finished, so it prints that one out. And then let's suppose the second one is finished, because it kind of is. We get a 0 there, and then we keep running. We get a new best x, best y. We pop down here and we failed. Where did we just fail from? We didn't fail from here, but we did fail. Interesting. So we need the address of that. Pull it down here. Copy. Data breakpoint. Run it. And it failed there. Change count is 0. Change max is huge. Best x, best y. Okay, are you telling me that on change q 3 12 times 30 is finished already? And how did it come out as the best x, best y? That doesn't make much sense, does it? Cell is finished. Oh, but we set right here that it's finished. Oh, and that's on change queue, and oh, the on change queue. I see the problem. I see a problem. So when we are done, where is it? When we are done with this whole loop here, we need to set on change queue change.x plus change.y width to 0. Alright, now it appears to be doing something, although that something is completely nonsensical and dumb. It's definitely doing something. 1010. Let's let it run without the debugging thing. So it got the right answer that time. Now we just got to smarten up how we're doing that sort of marking when a cell is changed and when to revisit it and when to blah 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 blah. So basically, I can always mark a cell as needing to go through the change queue, but then if a change actually occurs, then I hit a contradict. Like a finished cell should never actually have a change done to it, or it is contradictory. Before we get into this, I'd love to get into speeding it up, but actually I want to do one other thing. I want to get back, I want to do what it was originally meant to do, which is this sample set. Uh-oh. Did that cause a contradiction again? That looks like it did. Doesn't make any sense. Right. Fascinating. The thing is that interesting. So with any of these where it perfectly works, where the exact pattern is basically forced, there's only two variations that are even possible. Because like I could say here, like make this one 1,000 times more likely, and then it'll probably put the one on the left instead of on the right. But other than that, and that's just because since it's picking that first cell first, it's doing that. But obviously, since this is the only way to tile this, it's working. But if I give it a situation where there's a possibility that, like, if I give it both of these, apparently it's just going, no, I don't. I could see why it wouldn't want to tile both of those, perhaps. But I can't see why it wouldn't want to do, like, this one and this one. And it could always just ignore one of them and use the other one and make it work, unless it just so happens that once you put one down, it fails. But why would this fail? Like, if you had all ones across the top, right, and then all zeros, and you could put all ones. I guess you can't ever flip to the other one because then you get like zeros there, but you could do like all ones and then all ones and then all ones, but then you'd have to have, oh, but you've got both of those, that's the point. It seems like it should be tileable, so the fact that it's reaching a contradiction maybe means, I don't know what that means necessarily. Let's suppose for a moment I didn't add any noise. That doesn't have anything to do with it. Am I not picking? I wonder what order I'm picking. Well, actually, it's even when it's reaching a contradiction, it's never showing me more than one. So why don't we just go look and see where the contradiction is occurring, because it shouldn't be reaching one in one step anyway. That doesn't make any sense. What was that? What was that? Alright. So, this is wrong again. Copy this down, grab a copy of it, delete this one, add a data breakpoint, play it. Where did we hit that? Sample count. We're on step equals 1. Very interesting. You hit somebody with a sample count of 0. Can't believe that, because you couldn't have possibly... You only have one finished cell, right? So if we go to cell finished, 900, there's only one finished cell, which means there's got to be multiple resolutions to these other cells, right? So what is my x and my y? 128, way down there. That's right next door to a 29, like a 129, which is, so basically we have x equals 1, y equals 28. At x equals 1, y equals 29, we are up and to the right from the original spot. So it's looking at that, and there's only two possible things, and then somehow it got the concept, oh, it's not doing the OR correctly. It's not doing the OR correctly. Okay, T2. So for T1 to fail, then, okay, so this is a little bit wrong. Okay, I see. So here I found out that T1 and T2 don't coexist, but I need to find that out for all of these. So, yeah, what I need is like can coexist equals 0 initially, and then if we get to the end and that, then that end we break, right? Because if any one of the T1s will work with the sample T2, then they can still coexist. Is what I actually want. So this is more like we assume we can't, and then we try all of the possible samples, and if any one of them actually does coexist, then we break out. Now, it's inverted here in this part where we're saying we assume we can coexist until we find a contradiction, but there are multiple samples possibly, and we have to try each of those samples in the neighboring cell to actually make sure that we contradict with all of them before we eliminate a thing. So let's try that again. Badoop. 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 Doop. 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 Doop-a-doop. Alright, that didn't fail apparently. So there we go, it worked. It did what I wanted it to do. And now let me give it all of the samples that it should have been getting originally, because I think they should all be able to coexist. Interesting. So it kind of just decided not to do rows. I guess it might be hard for rows and columns to happen at the same time. Yeah. But you see that it looks like it decided let's just only do rows. Now, to play with this a little bit more, it'd be kind of interesting to say like, let's try a different concept. Let's take all of the blocks that have exactly 3 ones in them. So 1, 1, 1, 0, 0, 1, 1, 0, 0, 1, and that's just 1, 1, 1, 1. It made a bunch of like boxes, kinda neat. Okay, so now what we are starting to build up here, let me start labeling these. This is the diagonal, this is the columns. These are diagonals, columns, rows, L's. And let's do that. Alright, so now there shouldn't be any 2x2s that are solid 1 or solid 0 in there, and it doesn't look like there are, but it's got a healthy mix of all kinds of other stuff. Like here's a column, here's an L in a row, here's a kitty corner, here are some kitty corners here and here and here, and so on and so on and so on. So this is getting there. That looks like the right kind of thing. Now, one other thing to do to play around with this is, let's say we want lots of columns and rows as compared to everything else, just to see what kind of results we get, just for fun, to make sure that the weighting thing kind of works. And now we should see longer stretches of 1s and 0s, like there we go. And I think if we compare these two, this was before the weighting, this is the after the weighting. It looks like it maybe has some more rows in it. Hard to say for sure. This definitely has some rows in it too. This has some columns up here and stuff. Let's try and increase that again. I just want to get a feel for how much the weighting plays in, or if it looks like it's responding to the weighting correctly. Is that like more rows than before? More columns than before? Hey, that's a 2x2. Where the hell did that come from? What's this nonsense? That doesn't look correct. There's a bug. There's a bug. Look at that. That's bugs. That's a bug. That's a bug. These are bugs. There's still bugs everywhere. Bug. Where did all those bugs come from? Hey, there were bugs in the previous one. There and there. Where did all these bugs come from? Did they come from the entropy not being computed correctly because the weight's not being understood correctly? Because this doesn't appear to have any bugs, when all of them have the same weight. I don't see any bugs. Alright, so let's try something here. Since maybe the weight stuff isn't being computed correctly, let's say we did that, and see if we get back to no bugs. Because then we at least know, nah, see there's a bug there and there, there. Yeah. 1, 2, 3 bugs in this one, 4 bugs in this one, 5 bugs in this one, 6 bugs in this one. So it's not super. Let me just double check that this doesn't have any bugs. Alright, I'm going to try different random seeds here. Uh-oh. Gonna need an extra new line right there to make that work. Alright, so I ran it 10 times with 10 different random seeds. I should have gotten different boards each time. Looks like I did. And it looks like there are no bugs in any of them that I've seen so far. Yeah, so then if I pop up here to the 1111 stuff and I say let's make just a ton of diagonals. It should have introduced bugs. I do see a ton of diagonals now, which is fascinating. So I didn't think I was seeing that before. Lots of diagonals in this one. Did this just like not introduce any bugs? Okay, that's odd. Let's just do a bunch of columns then. There we go, now we've got bugs. And, do I have like rows and columns inverted or something? Those are rows, and I see, so there we go. Columns. And now we're getting bugs. Okay. So, how is that happening is the next thing to look at. And it's happening with a 0 instead of a 1, which is interesting. Possibly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there's no samples of all zeros, so the fact that it's... Is it like failing and then returning to me an incomplete thing anyway? No, if it fails, it's just supposed to fill it with zeros, right? Like we're down here. We're just supposed to go, yep, so it's not failing, it's just giving me buggy output with big blocks of zeros for some reason. So, let's take a look at what the first one looks like. Where is the... I need the one with the earliest block of zeros. this one. Okay, so that's 0, 1, 2. Alright, when I equals 2. So now what I'm going to do is set I equals like that. But I'm going to set this whole thing to go like that. And where's my random number generator? It's way up there. Let's pull it down to here and do like that. Okay. Now I want to turn my debugging back on. It's making very odd decisions about where to place things down. First. It should be making decisions that are near, it should be starting near the first one that it edits, but and that's the top left corner, but it's not doing that at all. So I feel like there's something wrong with just the entropy computation that I don't understand, and I can't like read out of the code correctly what something that I'm missing there. So let's just say have it go once and skip the first step of observation and look at the second step of observation, find the smallest entropy. So we look at the first one and that cell's already taken, so we go to the next one. Alright, so we go total weight went up 1, 2, 3, 4, 5. Okay, so it's got at least 2 valid samples. 3 valid samples. Alright, so the total weight can't be 1,000 and 10,002, can? Oh, I guess it can, because that could be if one of the alright, yeah, that makes sense. So I get the log of the total weight, which is this positive thing, and then I get each of the individual logs here. T is less than the sample count, plus T. Oh, I'm looping over all of the samples. I need an if here that says only add this in. Right? Well, let's take a look at what happens. Weight by log weight T was 0. Wait a minute. That's just a bunch of zeros, and then these two things? What's weight by log weight? That's, oh, log of 1 is 0. Okay, so each of the things that have a 1 are adding in 0. Now, I think this must have an if, because if it doesn't have an if, we would just do this the once, right? It's just going ba-do-do-do-do, and then we end up with this huge negative value, because the log total weight came from this total weight, which was like, 9-ish, and then this was like 18-ish. Or something like that. A little more than 18, because it got divided by total weight. But the entropy came out negative. Alright, let's go read the C# code, because I feel like there must be a mistake there. Well, let's see if I can find it first. Wave function collapse. Mixjamin, something like this. I don't know exactly who's responsible for this awesome little demonstration, but yes, we're only supposed to add that in if it's right. So what line is that? 320. So if if and entropy sum, we're looking at, where's the name of this? It's got cell coefficients t. Okay, now it's picking neighbors, which is good news. Alright, so there we go. No more bugs, and now it's just showing us that, yeah, when you set the columns to 10,000, you just get a bunch of columns. The probability is not in favor of getting anything else. So, and that's because if the likelihood of a column is 10,000, then the first few things become columns. It just becomes easier to keep picking columns because you eliminate things that don't line up with those columns as you go anyway, right? But that's good. That looks like it's working more. Let me go turn the debugging. Well, let's leave it on because there's another issue, which is that it shouldn't have had to do that many stages. And the reason it has to do that many stages is because this cell finished thing doesn't quite work. It doesn't know. It doesn't set this to true down later when we have the propagation can also finish cells, and we're not accounting for this yet. Right, so right here I need to do some work. But before we get to that, and that'll reduce the number of steps it needs to take, before we get to that, I want to do a little bit of fun, which is I want to find where I've got those, and let's reduce those down to 10, which is what I originally wanted, and see if we get more like what I was hoping to get. We gotta wait for it to run again, which will be interesting because now I can stop and see if it's still doing 4s and 5s on all locations. Oh, see, a 6 slipped in and a 9. So this is looking better. Yeah, this is very interesting now. It's doing this sort of ballooning out in odd directions. Ah, so cool. Alright, keep going, keep going. Still no contradictions. It still has a plan on how to fit everything together. Yep. Getting some 8s and 0s and 1s in there for some diagonal action. It's going to be so cool when it's done. It's going so slow right now because it's printing out like an entire 900 characters plus new lines every time it updates a single cell in there. So that's like 900 squared characters it needs to print in order to get done. And then in between each of those, it has to like turn off the printer and do a little bit of work and so on and so on. Yes, that is quite cool. So now we have kind of like, I don't know what you want to think of it as, like the sort of vines up a wall with little interleaving between them or something like this. I don't know how you want to think about what this represents, these 1s and 0s, but it's very cool. In my opinion, at least. It's got a few bigger imperfections, like this right here is fairly interesting. All the stuff that happened to form this little spot where it stops. Like some of these columns just go on from top to bottom, but right there, it broke that one. This column of 1s here looks unbroken. I guess all of them break except for that one. So maybe this is actually the odd one, these ones that are completely unbroken. But yeah, there we go. So that's looking correct. Alright, let's speed it up. Let's make it do fewer steps. So, down there at that to do, where it's like, we need to check for newly finished cells and contradictions, what I want to do is say, to check for contradictions, first of all, if the cell is finished at cell 2, x2 plus y2 times w, and we actually do need to make a change, then we failed, and go to finished, right? Rather than propagating more and discovering that we failed up there. So now what I can do is up there when we say go to finished, right here, we can actually just say I want like an assert, but I don't have it. So to do this can be an assert once we just start using that. Okay. Now, if it was not finished, what I want to do is I want to say, well, the dumbest possible thing I could do is while I'm actually, let's do this. So we have it up here, uint8t cell is finished equals, and that comes from this cell is finished, and that could be like cell 2 is finished, right? So if we find that we need to make a change, but cell 2 is supposed to be finished, then we've got a problem. If we come out the other end and cell 2 is finished is false, then what I'll do is I'll keep a count of state count, or potential state count equals 0, and then every time I'm inside this bracket, I've read a potential state that was not necessarily that might have been eliminated, but if I'm in here, then I know that it was not eliminated, because this else branch here only can happen if if the cell 2 originally had that state and we never contradicted it. So it can still coexist. Then I increment the potential state count. So if that is true, or if the cell 2 is not finished, and the potential state count equals 1, then what we can do is say cell finished x2 plus y2 times w equals 1. Alright, and that should decrease to some extent the number of stages this has to go through. And that looks like it's good doing it faster. There we go. That affected the results a little bit, which is interesting. I guess it's just because it's doing things in a different order, but it also, I don't know, that affected it quite a bit actually. Because now the 4s and 5s are even more common. Although, that might have actually been a bug that we didn't have that before, because that meant that cells that we shouldn't be visiting, we were actually like visiting a second time and then doing the propagation calculation a second time, but that shouldn't have necessarily changed anything. Yeah, I maybe should do some verification at some point, like try to verify at each stage that we're doing exactly what we think we're doing somehow. Because this doesn't have as much chaos as the last one. Like, it's got little hiccups in the pattern, but much fewer than the one we did before. And this is just off of changing how the order of events is supposed to happen, not really how anything else gets calculated. Interesting. Alright, so now what I want to do is I want to play with it. Let's see what time is it. Alright, we're 2 hours in. I'll make this a short stream by my standards anyway, by wrapping up in about half an hour. And until then, what I want to do is just play with what we've got and see if we can expose any issues or find interesting questions. Okay, so first of all, what if I ask for more rows as well? Do I get lots of rows and columns now? And I should turn that off for sure, so we can just get the answers immediately. I'll do that on the next one. Why did I leave? Oh, that's this. Alright. I was gonna ask, why did I leave my browser up for the whole stream? I normally close it to save computer power. Computational powers. So we're going blah 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 blah, doopy doopy doo, droopy doopy 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 doo. And there we go. Now we've got rows and columns, which is kind of neat. It looks like it preferred columns still, which is odd. Like, it should have made lots of rows, but really, this is the only spot where it really properly made a row. Like, these are L's here. That's, okay, these are rows here. But, like, all of this is columns, not rows. Which has something to do with the fact that once it decides to make a row there, it doesn't really have a lot of options to get out of making rows, because even though rows are supposed to be more common, it eliminates the possibility of seeing a row but maybe that's just because the things that would allow it to transition to rows aren't allowed to happen frequently enough. So let's increase those a little bit. And if you were to like feed it an input bitmap, that input bitmap would have the properties that allow these kinds of things to happen more fluidly. But another thing I want to do is I want to turn off the debugging thing. There we go. Now we've got plenty of both. There's a column, there's some row there, lots of column there, lots of row over here. Pretty cool. Okay. Let's talk about extending the kinds of samples we've got. So we've got these. Well, for one more thing, let's do this and this, and let's say this is going to be the well, first of all, we need the 3 ones case. So this is like take all of the ones, replace them with A's, take all of the zeros, replace them with ones, take all of the A's, replace them with zeros, and there you go, right? And then there's your L's, here's your corners. Neato. So now it's making like a maze. You see this? Do 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 do. If I don't let it make any kitty corners, it'll eliminate stuff like this right here. Yeah, it's making like a super tight maze because it's not allowed to have a 2x2 block of zeros. So it's only generating, if you think of like the ones as walls, then the zeros are spaces you can walk through, and it's not allowed to generate anything that is 2x2 either type. So it makes this really dense sort of maze thing, which is kind of awesome. Although it doesn't guarantee that any areas connect to each other. Interesting. Alright, so another thing we could do to take this up another notch is to say let's allow big blocks of zeros and big blocks of ones, right? Because then we can see the full set of possibilities with just differing amounts of like probability. So we'll call this big open space. We'll allow one big thick wall, one. There we go. Now it's made some small little areas, like regions here and there. There's a big thick wall there. Very neat. Depends on whether or not I can move along diagonals. It's like, is this NetHack or is it a different one, right? It would matter. Some of them don't have diagonal motion. Let's see. Yes. Okay, so that's interesting, but the more interesting stuff will really begin. Let's change this up a little bit. So let's make these really common, and let's leave those as not very common. There we go. So now we're doing something that looks like it could possibly be generating like a game level for a game. Right, so we have nice big open spaces, and then these sort of just spindling walls of differing shapes. And what I want to do is I want to introduce a new sample type for speckling in game items or something. So the new sample type will look like this. If we have, say, a corner, so let's take all of our corner types, and maybe sometimes in a corner you put a 2, which is a chest, right? And so we'll say here are the L's with treasure, and those will have a probability of being less common probability. And we also just basically need, if that's going to be the case, rows and columns. Let's reposition those so that it looks like everything else. Diagonals, rows, columns. So we can put a 2 there or there. We can put a 2 there or there. If I don't do this, then it won't ever be able to connect the 2 to, it won't ever actually be able to put a 2 in because there'll be no way to fit it into the pattern, right? Since everything that shows up on the output has to be a sample, if I skip this, oh, those are not diagonals. Those look like diagonals. Oh, I see. I see. Right, so that's a row, and this is a column here. So this column is going to need 2 versions. I see. So we need like, this is a column here, so the top and the bottom, and then again, with the bottom and, oh, we should do the top and the top, and then the bottom and the bottom, right? And so now I've got, what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 new ones. I also need, I'm still not done because if I just gave it that, it would still not have a way of, what's the word? It would still not have a way of putting the chest in because it needs something on these take care of all of the images where if it's in a corner, if it's flush against a row or a column. But what about the other position, right? There's the spot where you put the window, the 2x2 window, is in the open space with the 2 in the corner, right? And what I want to do is I want to make a rule that says you never see a 2 just out in open space. There's always a wall that kind of is in the way of getting to it. So you get something like this. Alright, you get like, well, basically I need a copy of the diagonal, which is what's up here. And for each of the diagonals, what I'm going to do is replace one of the walls with a chest. So that one and that one. Or that one and that one. So now what I have is 1, 2, 3, okay, 16 of these. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Fascinating. So it found another way to sneak a 2 in on me. Neato. Now, obviously, if I had a bigger window, so I'm doing a 2x2 window right now. If I used a bigger window, a 3x3 window, I could do more control to force all of the 2's to always go directly in corners. The problem with a 3x3 window is it's a lot of work to write out 3x3 windows by hand, but since we're taking some time to play with this before I sign off, I don't see any hurt in trying to write a 3x3 window. So let's do that. We'll make a small set of samples to kind of try to get that up off the ground. So let's come up here, and our new sample types are 3x3. Okay, so now each sample is going to have basically 3 rows, and the template for the sample will look like this. Alright, so there's one sample. Okay. So that'll give me something to work with. I want to do a similar thing for columns. Should be a little less straightforward. And this is where you'd really rather feed sample sort of bitmaps in, so then you can just draw your bitmaps and make them a little bigger than 3x3, make them like 6x6 or something, and use that as a way to sort of capture multiple sort of patterns and then pass those bitmaps in, and then have it extract 3x3 samples and do all of the rotations of them and stuff automatically, which the thing on the GitHub actually has all those features too. So we'll probably play with that at some point. Although I want to speed up the core before we get onto that. So there's columns. Then I want to add in bends, and a bend needs to look like kind of like first of all, there'd be like one like this. There'd be one like this. There'd be one like this. There'd be one like this. But of course, this is where it gets annoying, is that to allow all these, I also need the same thing sort of shifted over a little bit. So we get something like that. 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 And that. And then I also want bends for this type of thing, so I need to do some of those, which look like maybe like this, or like this, or they might look like They might look like this, or they might look like this, right? So there we go. Now we've got a nice set of possible things. Now I want to make the sample counts for each of these. So how many are there? There's this is open space. What I'll do is I'll just grab all these. I'll copy it and I'll paste it. I'll lose the auto indent and then I'll fix it. And then test samples occurrences. Occurrences looks like that. So this first thing will occur with a frequency of 1 to begin with. This will occur with a frequency of 1. This will occur with a frequency of 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. There's probably a smarter way I could have done this if I had done like a mem set on an array that was the right size or something. Mem setting with integers doesn't quite work because you have like, if you mem set 1, you get like all 4 bytes of each integer is a 1. Alright, so how many are this? This is 1, well, here I'm on character number 272. There I'm on, wait, 5 and 35, so there's 30 characters, which means there's 15 of these things. That doesn't make sense. Should be more than 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. There should be 12. Here I'm on character 5, there I'm on character 30. Which means there's 15. One, two, three, 4, 5, 6, 7. Okay, so there's basically 1, 2, 3, 4 of those kinds of bends. There should be one, two, three, 4, 5. 1, 2, 3, 4 of each of these. For each bend type, I have 4 types of bends. That shows up once there, once for each of these. I'm missing 4 here. It should be 16. Where did the other 4 go? So these here all need a version that goes with all zeros on one side. Right? So that should go there, that should go there, that should go there. And technically I should have even more than that because each of these here should also have a version. There's actually 20 of these. You can see why I want to avoid doing 3x3 samples by hand, I presume. Well, you know, if I was not dumb, what I would do is I would okay. So now I have 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12. Yes, there we go. So the difference is now I can just keep on pasting this line everywhere. Right, so find that, get rid of that. Whoops, wrong side though. No, oh, there we go. Alright. So let's see, that is 20 of these things. So 4 for the originals, 4 shifted one direction, 4 shifted the other direction, 4 shifted both directions, and then 4 for having a dot in them. Now, I also need to come down here to where I set like sample init. Just take me to main. I can't remember the names of these things. Yes, the samples are 3 by 3 now. Run that. Uh-oh, it failed. I wonder why. Let's go back up to the test samples. Let's just say none of that exists. Or let's just keep that. And that. Then we can do is we can take out that and that, and maybe that won't fail. Alright, so even that is failing. Alright, so that's not failing. That's weird. Seems like the very simple case of just having that one single tile type with a row shouldn't be failing, because it'll just create long strands of one. Oh, I guess it failed because maybe it added a row, but okay, so it needs at least that much. There we go. So that works. We can also add in the next one, hopefully. There we go. So we end up with a couple of those. And that seems fine. Good. Now, let's suppose we added in columns, and then it's going to fail, because if it doesn't have a way of handling a column meeting a row, it's going to fail if I add these in. So somewhere it's going to try to put in a row, somewhere else it's going to put in a column, and those will have to meet somewhere. Oh hey, it just stuck with columns everywhere. That's interesting. So no fails yet. Suppose I start adding in bends. Bend. I'll leave the fancy type of bend out. It might be upset that it doesn't have some T's. Maybe it would help better if it also had T's to help bind things together. Yeah, so there it failed. So let's try adding in T's and calling it a day. So to do t's, all we need to do is take all of the bends that aren't completely flush with one side of the window. So that means all of these 12 bend snapshots. And we need to add them and then figure out how many things we need to do for a t. So there we go. That and that will turn out the same. There we go. These two turn out the same. There we go. These two turn out the same, and that turns out the same as the one above it. So there's 4 t's there. Here we might need some more. No, we should only need 4 here too, because there's 1, there's 2, 3. I think that's all the t's you can make. We might want a plus. And when I think about it, it might also just want corners. Like, I'll show you what I mean. Corners, which would be kind of like, so it needs 4 corners and, what, 8 t's? Nine t's. Let's see if I can add that back in. And all of those. Still fails. Alright, well, we tried. I think next time we'll probably make the thing to build a proper sample set automatically. But maybe, no, first I should do the optimizations. But it doesn't look like it's bugged to me. It just looks like having trouble building a sample set that is sort of natural. But this is not a bad result either. Let's do one other thing to play with this. Do 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 do. Alright, so let's see if any of these are bad. I would be surprised if they are. Look at that, it's got like a winding passage that, oh, it's completely cut off from everything else, but it's got like a little 2 tucked away at the end there. This rule tends to like to put the 2's hidden away inside. Well, here you can get to this 2 from the main region, which is over here. You can come in and get that 2 and these 2's here and here. You could also make things that are required to exist in open areas. I kind of want to do that. And the way you would do that is you'd take this this open one, you just make 4 copies of it, and each of those needs to become want to call this? Like, statue 1111. So now it's putting little threes here and there randomly. Very cool, very cool. Alright, so I'm happy with this. I think we've got the bugs fixed. We need to speed it up, and then we need to be able to do sort of bigger sample, or pulling samples out of a bigger sample. Dave Chat is asking if I'm uploading this to GitHub. You know, I don't see any reason why not to, so sure, I'll put this all on GitHub. No problem with that. But thanks everybody for coming out to the stream and following along with whatever you saw. I'll see you guys later. Bye bye.